So far, we saw how quadratic equation, what is equation, and how quadratic equation behave, and which type of degree is uh, used to determine whether the particular equation is quadratic or not, or then how quadratic equation resembles in a Cartesian plane. It resembles like a parabola, and the general form of the equation, and then how to find the value of roots and the general formula of finding the values of the roots, and what is determinant, then how determinant behaves when the value is positive, when the value is equal to 0, and when the value is less than 0, etc. And we also saw the relationship between the coefficients of the equations along with the sum and the along with the sum of the roots and the product of the root. So now let's see further more properties, how we could expand this sum and product as a sum and product of the roots as a relationship, and could find a pattern how it's dealing up with the quadratic equation. So far we saw minus b by a is equal to sum of the roots, and c by a is equal to the product of the roots. Let me just expand. So let alpha beta be the roots, and alpha plus beta is equal to sum of the roots, which is minus b by a, and alpha beta is equal to c by a, which is product of the roots. So now let us expand furthermore. For example, alpha plus beta is equal to minus b by a, and alpha beta equal to c by a. And now alpha square plus beta square. So alpha square plus beta square can be extracted from, we all know the main property a plus b the whole square. A plus b the whole square is equal to a square plus b square plus 2ab. So we want a square plus b square. So we will be transposing the 2ab from RHS to LHS, which would end up getting us a plus b the whole square minus 2ab. So we are just substituting a as alpha and b as beta. So here alpha square plus beta square is equal to alpha plus beta the whole square minus 2 alpha beta. And we are just substituting alpha plus beta as minus b by a, and alpha beta as c by a. So we would end up getting b square minus 2ac divided by a square, which is alpha square plus beta square. Same way, we are just solving alpha cube plus beta cube from the relation we all know. A plus b the whole cube is equal to a cube plus b cube plus 3ab of a plus b. And we are just transposing that RHS term, uh, 3ab of a plus b to LHS, and just substituting a as alpha and b as beta. So we would get alpha cube plus beta cube is equal to alpha plus beta the whole cube minus 3 alpha beta of alpha plus beta. And we can also expand this as with respect to the coefficients, minus b by a the whole cube minus 3 c by a into minus b by a. In such a way, you could expand the same thing and you could proceed further. I just did it in order to find the pattern, and you can just substitute and get the relationship for this particular formula, and same way in further more results also. So alpha power 4 plus beta power 4, which is equal to alpha cube plus beta cube of alpha plus beta minus alpha beta of alpha square plus beta square. For this, we have to know alpha plus beta, alpha square plus beta square, alpha cube and beta cube. So these three we need to know in order to get the relationship of alpha power 4 plus beta power 4. To be honest, quadratic equation can be solved by two choices. One is factorization and the other one is using these relationships. If you find this relationship is hard to remember and hard to derive it on the spot, then you could go with the factorization method. Just through trial and error, just finding out the matching the coefficient with the sum and the product and doing this. For example, if you see ax square plus bx plus c is equal to 0, and I have taken example equation x square minus 3x plus 2 is equal to 0. So I have to get a sum which is 3, sum of the roots is 3 and the product of the roots is 2. Okay. So sum of the roots is 3 and product of the roots is 2. So for in order to get a product of 2, I should either multiply 1 and 2. That's the best option. And even 1 and 2, if I add together, I would get the answer as 3. So yes, it's matching. So in this way, you have to match it up through trial and error method, and you can factorize that easily, and you can get the roots that easy. And if they ask you to find alpha per 4 plus beta per 4, then you can derive that either alpha is 2 and beta is 1, and you can just substitute and you would get the answer. If at all the equation is really complex and you could not achieve that through trial and error, then you can use these relationships as an example. So for alpha per 4 plus beta per 4, we need to know alpha plus beta, alpha square plus beta square, and the relation alpha cube plus beta cube. With that only you can achieve, achieve the result of alpha per 4 plus beta per 4. Same way for alpha power 5 plus beta power 5 also same. Alpha square plus beta square you need to know, alpha cube plus beta cube you need to know, and alpha beta you need to know, and alpha plus beta also you need to know. With that only you can expand this relationship. So alpha power 5 plus beta power 5 can be written as alpha cube plus beta cube of alpha square plus beta square minus alpha square beta square of alpha plus beta. So this would sounds really tough to memorize or something like that, but you can practice this. Else, if you don't want to do it that, yeah, you're welcome. You can just factorize the roots and you can get the roots very easily. And then just substitute one root as alpha and another root as beta and just solve it. You end up getting very easy results. So we all saw how roots behave with the addition, in the sense sum. So how roots behave in difference. Now let's see how roots behave in difference. So modulus of alpha minus beta. Modulus means the value should always be greater than 0. In the sense, whatever negative value you get, it would be turned into a positive value. That's where the modulus function is used. So modulus of alpha minus beta is root over alpha square plus alpha plus beta the whole square minus 4 alpha beta. Okay, you all get doubt how this we got. I would just tell you using the same relationship alpha plus beta the whole square, which means a plus b the whole square is a square plus 2ab plus b square, right? I'm just rewriting the same thing as a square plus b square plus 2ab. And in order to get alpha minus beta, uh, I have to, in the sense alpha minus beta the whole square would give me alpha square plus beta square minus 2 alpha beta. But what I have is alpha square plus beta square plus 2 alpha beta. So for that, in order to turn that plus 2 alpha beta into minus 2 alpha beta, I'm just putting minus 4 alpha beta. So plus 2 minus 4 would give me minus 2 as the coefficient. So in such a way, you can get alpha square plus beta square minus 2 alpha beta, which would give me alpha minus beta the whole square. And if I take square root on both sides, and I would end up getting plus or minus alpha minus beta. Plus or minus alpha minus beta, if I have to avoid plus or minus alpha minus beta, then I can just put a modulus so that all values would be positive. So in such a way you can do it, and even you can just expand the same using alpha plus beta. You can substitute as minus b by a, and alpha beta you can substitute as c by a, and you can just expand the same. So you would get root over b square minus 4ac divided by a square. So root of a square would give me a. So which is nothing but root of delta divided by a. That is what alpha minus beta is. Same way, alpha square minus beta square. We all know a square minus b square can be written as a plus b into a minus b. Correct? Same way, we are just expanding the same equation. A square minus b square can be written as a plus b of a minus b. Same way we are doing alpha plus beta of alpha minus beta, and I am just substituting the results what we got from the first equation, which is alpha plus beta minus b by a, and alpha minus beta what we got is here. So plus or minus root over b square minus 4ac divided by root over a square. So I am just putting root for this numerator, and I would get minus b by a dot product of plus or minus root over b square minus 4ac divided by a. And a if you multiply in the denominator, I would get a square. And minus b into plus or minus root over delta. This is what you can write this off. Alpha square minus beta square. You can expand like this. Okay. Same way, alpha cube minus beta cube. Alpha cube minus beta cube. We are just using the same algebraic expression. A cube minus b cube can be written as a minus b of a plus b whole square minus ab. Same thing we are doing here. And we are just substituting alpha in place of a and beta in place of b. That's it. Same way, we are just doing alpha power 4 minus beta power 4, and we would expand this as alpha plus beta of alpha minus beta of alpha square plus beta square. For this, we have to get first relation, that is alpha plus beta, which is equal to minus b by a, and alpha minus beta, which we just derived it, and then alpha square plus beta square, which is nothing but alpha plus beta the whole square minus 2 alpha beta. Correct? And one more important thing, in order for a quadratic equation, it should be of the form ax square plus bx plus c is equal to 0, where a should not be equal to 0. Why? Because if a equal to 0, then there is nothing used that the degree would be 2. So 0x square means it's a term which is nothing exists. So the quadratic equation would be reduced to linear equation. So the degree would be turned from 2 to 1, and there is literally nothing meaning exists, and it is not a quadratic equation basically. So the parabola would become a straight line indirectly if the coefficient of x square is 0. So we have to note this important point. Ax square plus bx plus c is equal to 0 is the quadratic equation if and only if a not equal to 0. So let's solve some numericals. Here alpha, beta are the roots. For this particular equation, 2x square plus 6x plus b is equal to 0, where b is negative term. Then alpha divided by beta plus beta divided by alpha is less than what? So let's solve. Alpha divided by beta plus beta divided by alpha can be written as, while cross multiplication, we would get alpha square, then plus beta square divided by alpha beta. Okay. So alpha square plus beta, we all know alpha plus beta is equal to minus b by a. So minus 6 divided by 2, which is minus 3. And alpha beta is equal to c by a, which is b by 2. And I am just substituting this. Now alpha square plus beta square can be expanded as alpha plus beta the whole square minus 2 alpha beta. Alpha plus beta the whole square minus 2 alpha beta divided by alpha beta. Alpha plus beta the whole square is minus 3 the whole square minus 2 of b divided by 2, which means 9 minus b divided by alpha beta is b by 2. So we would get b by 2, which means if I multiply this 2 to numerator, I would get 18 minus 2b divided by b. So alpha divided by beta plus beta divided by alpha is equal to 18 by minus 2b divided by b, which you can separate it. So 18 minus 2b divided by b can be written as 18 divided by b minus 2b divided by b. So my 18 divided by b minus 2, and we all saw b is less than 0, which means it's negative. Okay, so 18 divided by b would be negative, and already minus 2 is there, and the options given are option A is 2, option B is minus 2, option C is 18, option D is 20. So minus 2 would end up giving me a negative result, which is ultimately less than 0. You can ask me minus 3 is greater than minus 2. No, minus 3 is always less than minus 2. So here, whenever the negative mark is going, so you would always get, minus negative of minus 2 means it's less than minus 2. So the answer is option B and not option D, to be noted. Here it's given wrong, so option is minus 2. So it's the result is less than minus 2. Okay. Same way you can solve this. Alpha comma beta roots are the roots of this equation. X square plus 3x plus 2 is equal to 0. Find alpha power 5 plus beta power 5. As I already told you, there exist two methods. Method 1 using coefficients and method 2 using factorization. So now I'll solve it through factorization, and let's just match the results with that. So method 2 is alpha square, x square plus dx plus 2 is equal to 0. X square plus, I have to get sum as 3 and product as 2, which means x square plus 2 plus 1 of x plus 2 into 1 is equal to 0, which means x square plus 2x plus x plus 2 is equal to 0, which I would get x plus 1 of x plus 2, and then the value will be x is equal to minus 1 or x is equal to minus 2, and I am just taking minus 1 as alpha and minus 2 as beta. So I am just substituting the same. Alpha power 5 plus beta power 5 minus 1 power 5 plus minus 2 power 5. I would end up getting minus 1 plus of minus 32, which would give me minus 33. Same thing. I would do the same using coefficient. Now let's just verify the results. Alpha power 5 plus beta power 5 can be written as alpha cube plus beta cube of alpha square plus beta square minus alpha square beta square of alpha plus beta. Alpha cube plus beta cube can be written as alpha plus beta the whole cube minus 3 alpha beta of alpha plus beta. So same way, minus 3 the whole cube minus 3 of 2 of minus 3, and I would get value as minus 9. Then alpha square plus beta square can be written as minus 3 the whole square minus 2 of 2, which would give me 9 minus 4, which is equal to 5. So while substituting, I would get minus 9 the minus 9 into minus 5, minus 9 into 5 minus 4 into minus 3. So I would get minus 45 plus 12, which should give me minus 33. So yes, minus 33 and minus 33 is matching. Hence method 1 and method 2, same answer we would get. So yes, if there exists more number of time, and you in the sense, if you got more time, you can just use coefficient method, and if you get very less time and you can easily factorize the things, then better to choose factorization method, because this is you have to find the coefficient and you have to substitute this, so it is a steady long process, you need time. Okay, let's see further numericals in next episode. Please like, share and subscribe to our channel for more videos based on maths, science, physics, chemistry, and engineering related topics. Thank you.